So now we're going to look at a couple of composite area problems. So recall from earlier grades that composite areas were usually areas that were made up of one or two different shapes. Okay, we can either use addition or subtraction to get our final answers. So we'll start with part A, sketch the curves y equals x squared and y equals x minus 2 all squared on one set of axes. So let's start by doing that. They're both fairly basic parabolas that we know lots about. So that's going to look like y equals x squared. We know that that looks like this. And y equals x minus 2 is the same parabola shifted 2 units in the positive direction. Okay, so it's going to belong, the vertex of which is going to be somewhere along here. So that's 2 units. This is going to look like that. Alright, so we've sketched both of our curves on a set of axes. Part B says shade the region bounded by the curve y equals x squared, y equals x minus 2 all squared, and the x-axis. So that section in there, and I'm going to do this in 2 different colours. Alright, that section in there is this little triangle-y looking area underneath both curves and between the x-axis. So I'm going to draw one of them in sort of half of it in red and the other half in green. Alright, because we're going to have to do this in 2 different steps. So we want to be able to compute the red area and the green area and add the 2 together and get our total area. So let's think about the information that we're going to need. For the red section, we're going to need to set up an integral with respect to x. And which function is it underneath? It's underneath the x squared function. All right, so it's going to have an integral involving the function x squared. So let's just call it area. And it's going to be going from this section, or this part here, which is 0, to some value up here. Okay, so to here, let's call it a for the time being. And the next integral, the green one, it's going to be going from this value a to the vertex of it, which is 2. Okay, and it's of the function x minus 2 squared with respect to x. So the point is, we need to figure out what the upper bound of the red integral is and the lower bound of the right integral is. And that just so happens to be the x-coordinate of the point of intersection of these 2 curves. So we need to decide where that is. So points of intersection, remember, is when we set the 2 functions equal to one another and solve. So our 2 functions being x squared and x minus 2 squared, and we need to solve this. So how do we do it? Let's expand the right hand side. We get x squared equals x squared minus 4x plus 4. When I take the x squared over this side, it's going to cancel with that one. And if I drag the 4x over this side, right, the equation will become 4x equals 4, which in turn gives us x equals 1. All right, so the x coordinate is 1, and I don't really care what the y coordinate is. All right, I only need to know what the x coordinate is, because that allows me to fill in the rest of my integral. Alright, so we've now just got 2 integrals to compute to get our total area. So, the primitive function, which is going to be 1/3 x cubed, evaluated at 1 and 0, plus, in this case, the primitive function will be, it's going to be x plus x minus 2, sorry, the index is going to increase. And on the bottom, we're going to have 3 times the coefficient of x, which just happens to be 3, times 1, and then we get evaluated at 2 and 1. So finishing this one off, when I plug 1 in, I get 1/3. When I plug 0 in, I get nothing. So this guy just happens to be 1/3. What happens when I plug 2 in? Alright, so I'm going to put square brackets around this section. When I plug 2 in, I get 0 on the numerator, so it just becomes 0. Minus, now what happens when I put 1 in? I get 1 minus 2, which is minus 1. And when I cube minus 1, I get minus 1 as well. Minus 1 over 3 is minus a third. So I get a third plus, now it's minus negative a third. So that's plus a third as well. And that all works out to be 2/3 units squared. Right, so fairly basic one there. Right, our next question says, find the 2 points where the curve y equals x minus 2 squared meets the line y equals x. Draw a sketch and shade the area of the region between these two graphs, and then find the shaded area. So part A and B is not going to require any calculus at all. Part C is where we have to start doing our integration. So find the 2 points where the curve x minus 2 squared meets the line y equals x. So again, simultaneous equations. We're only interested in the x coordinates, so I need to set the two x, well, the parts that depend on x set to each other. So we've got x minus 2 squared equals x. Expand the left-hand side, we get x squared minus 4x plus 4 equals x. Let's drag this x over here. We get x squared minus 5x plus 4 equals 0, which factorizes to minus 4 minus 1, and I get x is 4 and 1. All right, that's part A done. Part B says to sketch. So nice and big, so you can include all of this information on it. So the parabola x minus 2 all squared, again, is the one that we saw from the previous example. It looks like this, and the line y equals x looks like this. Alright, it says draw a sketch and shade the area of the region between these two graphs. So that region just happens to be this section. So, how do we determine what the value of that shaded red section is? What you need to notice that this is actually a composite area. So if we were to think about the two graphs were two separate graphs, all right, let's draw y equals x first. So it looks like that. And the area that we're talking about, obviously, let's just skip back to this one because we've got to incorporate the parts that we did in A. So this point here, this first point of intersection, that has an x coordinate of 1, so that's 1 something. And this coordinate here has an x coordinate of 4. So in other words, we've got 1 here, we've got 4 here. So, back to what we were doing just a second ago. If we were to consider both of these two functions separately, the line y equals x between 1 and 4, it looks like this. Looking at the other function, I'm just going to sort of draw this all together a bit. The other function, which was the parabola, and it looks like this. And in that same region, so between 1 and 4, its area looked like this. So if you're thinking about what area we're actually looking for, it's this little in-between area in that. So that is effectively the red area, this red sort of trapezium shape. Take away this little archy looking shape. All right, so in other words, it's that take away that, and that's going to leave us with that sort of shape, which is what we're looking for. So let's set ourselves up an integral. For the red area, it's going to be the integral between 1 and 4 of the linear function, which happened to be x with respect to x. And then we're going to take away the green integral, which was the same thing, 1 to 4. This time it was x minus 2 squared with respect to x. So that's what's going to give us our blue area. Alright. Now, a handy thing that you can do with integrals when they both have the same upper and lower limits is you can combine them into one. So what I can do is I can rewrite this thing as the integral from 1 to 4 of x minus 2 all squared with respect to x, which we can tidy up. So doing a quick expansion of this, that turns into the integral from 1 to 4 of x minus, this is x squared minus 4x plus 4 with respect to x. And we'll keep going with that. Keep going with that. We get integral from 1 to 4. It's going to be x take away minus 4x. Alright, well, we've also got this minus x squared, so it'll be minus x squared. Then there'll be an x take away minus 4x, so plus 5x, and then a minus 4. Okay, so we've combined those into one integral, and now we're good to go. So primitive function is going to be minus 1/3 x cubed plus 5 on 2x squared minus 4x, between 4 and 1. And now we just need to do the substitutions. So when I plug 4 in, I get 4 cubed is 64. 4 times 4 is 16 times 4. Yep, 64. So minus 64 on 3. Plus, this is 4 squared, which is 16. 5 16s are 80 over 2. Minus 4 4s are 16. Minus, now we chuck 1 in. We get minus 1/3 plus 5 on 2 minus 4. Alright, so this is now a calculator question. And I get, for the first bracket, minus 64 on 3 plus 80 on 2, which is 40, minus 16. That first bracket is 8 over 3. Second bracket is minus 1/3 plus 5 on 2 minus 4, which is minus 11 on 6. So minus 11 on 6. And putting that all together, we get 8 on 3 minus 11 on 6. We get 9 on 2. Or you could write that as 4.5, or you could write that as 4.5 units squared.